I've been thinking about so many words to introduce you to Jo, and seeing her in that dress, I just can't find any. There are no words to describe the awesomeness that's right next to me. So please, give it up for our last talk of the day, Jo Franchetti.
Thank you so much for having me, and it's such a pleasure to speak to you all today. And I am here to talk to you about my wedding dress. Okay, so my name is Jo Franchetti, and I am a developer advocate. If you can't tell, I'm from London in the UK, where all the politics is exploding at the moment. I, as a developer advocate, get to make a lot of fun, silly projects so that I can then talk about them in front of audiences. And some things that I've made recently include a virtual reality game based on the comic XKCD. I don't know if XKCD has made it out here. Does anybody know XKCD? Do you remember this one that had the emoji sports? I decided to make a virtual reality hedgehog curling game where you can throw a hedgehog down an ice rink in VR, which is this game here. Also, the vitally important Biscuit Tinder, where you can rate your favorite biscuits. And I also have something to confess to you. I am a notification addict. And I don't know if any of you feel the same way, but I love getting that little reminder that someone out in the world is thinking about me. Not only that, but I get very anxious, like actual real withdrawal, if I'm away from a network connection for too long. And I like knowing that I'm connected, that I can get all that data that I want. So I thought that I would tell you the story about my enabling my own network addiction, which is really what made me decide to build this dress. So let's start at the beginning of this story. And it begins at an EMF camp long, long ago. Now, if you don't know what EMF camp is, for want of a better description, it's a bit like Glastonbury Festival for nerds. So EMF stands for electromagnetic field, because it's in a field. That's the pun. And it's a place where hackers and programmers bring their projects, they camp for a weekend, and they show off what they've made, they build new things, they give talks, everybody learns, and it's great fun. And at one of these camps, somebody brought a giant inflatable bunny rabbit. And when I say giant, I mean this thing was about 3 meters tall. And it had LEDs in it. And it also had its own Twitter account. And you could tweet a color to it, and it would change to that color. And I really loved this idea. Changing the way that we interact with tweets really resonated with me. When we tweet, we're broadcasting an idea that we want other people to react to and to respond to. But the inflatable bunny took this idea from the virtual world to the physical world, and it changed something actually in your environment that you could respond to in an entirely different way. And I started wondering what it would be like if we could have a thing in our physical environment that our friends and our loved ones could just change the color of, just to let us know that they're thinking about us. No words, just, a nice change of color. You could delight or surprise someone from half the world away. And the scenario, kind of like that famous scene from Sleeping Beauty, played out in my head. You might recognize this one, where two people could be warring to change the color of the rabbit. I want the rabbit pink, no blue, no pink. And then I thought, what if the LEDs in the rabbit were on something wearable? What if they were in a dress like this one? What if they were in my wedding dress? My friends and anyone from around the world would be able to change the color of my dress and let me know that they're thinking about me. And it would be like having their thoughts and well wishes right there with me while I was walking down the aisle. So here began my quest to make a tweetable, light-up wedding dress. But my quest almost instantly hit a brick wall. And I was really excited about the idea. But I had genuinely no idea where to start. Now, I studied electronics at uni, so that means that I should just know all of this stuff, right? And I'm a web developer, so working with the Twitter API and reading the tweets with JavaScript should be a walk in the park, and yet I wasn't certain what tech to use. Now, I spend a lot of my time battling something called imposter syndrome, which is the idea that everyone around you knows more than you, that everyone knows everything, that one day you're going to slip up and everyone around you is going to find out that you don't belong, that you don't know what you're doing, that you're a fraud. Has anyone else ever felt this way? Some of you. And to be honest, it's very prevalent in the tech industry. We spend our time with lots of intelligent and brilliant and incredible people. And it's not surprising that we're going to compare ourselves to them and to do so unfavorably. So I was a little bit afraid to ask for help because I was afraid to show that I wasn't entirely sure what I was doing. And not only that, but I also suffer from anxiety related to perfectionism. And this sometimes stops me from even getting started on projects. Have you ever had that feeling where you know what you want to do, but you're not sure which tech to start, so maybe you try a few different things and discard them because they're not quite perfect, and you never actually get started on the project? That's perfectionism in action. So I found it tough to get my idea off the ground. I knew that I needed some sort of lights. I knew that I'd probably need a board that was connected to them. I'd need some sort of power, but beyond that, I just had no idea. So I did what I always do when I'm procrastinating on starting a project, and I went on Twitter. And if you haven't already noticed, I am a little bit addicted to Twitter, but I needed a starting point. So I asked for advice from my fellows in the tech industry what they would do if they were going to start such a project. And the response was kind of amazing. Yeah, it was a lot of information. So, that was incredible. So what did I learn from that? Well, firstly, there is this board here, which is called the Adafruit Feather Hussar, which measures about 5 centimeters by 2 centimeters, so it's really tiny. And it only weighs 6 grams, so it's perfect to go in something wearable. It has Wi-Fi, which means that I'll be able to connect to the internet and send colors to it. And it's got a USB connector, so I'll be able to power it with a normal battery charger. It also means that I can easily connect it to my computer and upload the code from an IDE. So that board is absolutely great. It cost about 20 euros, which is well within my budget, so that was great. I also learned that Adafruit make these little things here, which are called NeoPixels, which are individual programmable RGB LEDs. And they're lightweight, and they're tiny, and they've got nice little interfaces around the edge for conductive thread so that you can sew them into clothing. And they've got some really great documentation, so they've written a whole load of code examples for you so you can get up and going instantly. But they cost about 2 euros each, and I needed like 200 of them in the dress, so that was way over budget. So, oh, here we go. So what did I actually end up buying? Well, I bought the Adafruit because that was pretty much perfect for what I needed, and after some time searching around the internet on places like Amazon and eBay and AliExpress, I found these Chinese knockoff versions of the Adafruit NeoPixels, which were 25 euros for 100, which was well within my budget. And they've also got a white board, which is nice, because they were going in the white dress, so hopefully they won't show up. They don't have that nice interface for the sewing, but honestly, I can't sew to save my life, so I don't know who I was kidding. I was going to glue those things in there anyway. I also bought a soldering iron and all the stuff that goes with it, so solder sucker, etc. And my initial plan, as I said, had involved conductive thread, but having spoken to the people on Twitter, they told me that conductive thread actually has a very high resistance, and if you want, for example, 200 lights in a row, it's just not going to work. You'll get about 10 lights lit up, some lights faded and then nothing. So instead, I decided to go for this single core copper wire, which meant that I would have to solder each LED individually. But like I said, I can't sew, so I don't really know who I was kidding with the conductive thread. Instead, I went for the copper wire. I decided I was going to make my own skirt out of this netting here, and then I would glue the LEDs in and solder them all up together. But then I now had all the gear, but very little idea of what to actually do next. So I lent on the community again for some help, and I went along to a hackathon, which is a really brilliant way to meet a whole bunch of very enthusiastic people if you're not sure about what you're doing. And I met some really great people who got me set up with the board, who showed me how to use the Arduino IDE. And so I'm going to talk you through that now. I'm going to try and be those people for you. So first of all, the Arduino IDE is what you use to code for the board. So you're going to need to install that if you want to get started. You can use this with any board. It doesn't have to be the Adafruit Feather. It can be any Arduino, any Adafruit. They've got a whole load of brilliant documentation and a whole load of supported boards. And it comes with a whole bunch of libraries and example code. So the next thing that you're going to want to do is to install the code for the particular board that you're using. You can see I've done this here. So if you go to File Preferences, then you need to tell it which board manager you want, which I've done here. So this Arduino ESP8266 is the name of the chip on the board, so that's the package manager that I want to use. If you're using a different board, the Arduino IDE website will tell you where to get the package manager that you need, or your favorite search engine. So once you've done that, then you need to tell it to use that board. So we go to Tools, and we say, use the Adafruit Feather Huzzah. And once you've done that, you will have a whole load of examples for how to use the various things on the board. For example, the Wi-Fi, which is going to be useful to us later on. And then what you want to do is install the libraries that are going to make the NeoPixels work, so those little lights that I bought. That comes in the library manager, so we just search for NeoPixel, find the right library, and click Install. It really couldn't be easier. It's lovely. And once we've done that, that gives us a whole load of example code to test the lights out, including this one, which I used here, which is the strand test, which will send a whole load of rainbow lights down your strand of LEDs, and we'll check that they're all connected up again properly. It also gave me the example code to see how to send a single color to the LEDs, which is what I needed. So far I have how to connect to Wi-Fi and how to send a color to my LEDs already without having to write any code myself. So the next thing that I needed to do was to connect up my LEDs. This is a close-up of what each of the LEDs look like. And I soldered them together with short strips of that single core wire. Now, they have markings on the back to tell you what to connect with, and importantly, in which direction to connect. Remember this for later. So you can easily see which lines you need to connect. So make sure you've got your power to your power, your ground to your ground, and the middle line is your data. So next up, I need to connect my string of LEDs to my board. So I was using a USB battery to power it, so I'm sending the 5 volts into the USB pin. I've got ground to the ground, and then I chose to use pin number 4 to be my data out. You can use that one, or you can use one of the other ones. It's entirely up to you. So the final thing that I had to do was upload the strand test to the board and connect up the battery and see if it worked. And it did. My lights are now working. So I have my board, I have my lights. So what's next? I needed some way to send a color to them from Twitter. But before we talk about how we did that, let's just go through a little bit of theory about how RGB LEDs actually work. Now, for those of you who are au fait with CSS, this should be fairly recognizable. So remember in school when you mix paints together, you were told that there are 3 primary colors. We've got red, we've got yellow, and we've got blue. And you might have been given a color mixing chart that looks something like this. So you mix red and blue together, you get purple. You mix red and yellow together, you get orange. And when you mix all three colors together, you get this sort of blacky brown sludge color. So that's paints, but we're using light. And light has different primary colors. Instead of red, yellow, and blue, we've got red, green, and blue. And they combine like this. So red and blue is purple, red and green is yellow, and blue and green is this sort of cyan color. And when you mix them all together, you get white. So why does this matter? The RGB in RGB LED stands for red, blue, green. And inside each little neopixel is 3 individual LEDs. And you can set the brightness of each of these LEDs to either full brightness or no brightness, and we can make a whole load of colors by setting the brightness of each of these LEDs. And due to the human eyes not being that great, and the LEDs being very close to each other, we see the 3 combined as one light. So here is our little pixel with each of its individual LEDs, and we can give a value to each of those. And those of you who write CSS should recognize these numbers. They are between 0 and 255, 0 being completely turned off, 255 being the highest that it can possibly be, the brightest that it can be. So, for example, if I set the color to 25500, what color would the bulb turn? Red, yeah. And how about 2550255? So we've got full on in red, no green, full on in blue. Yeah, sort of purple, some people might call it magenta. And these are our RGB values, which is lovely, but I don't want the people who are tweeting at the dress to have to know all of the things that I just taught you. I want them to be able to tweet the word blue and for the dress to turn blue. I don't want them to have to tweet 0, 255, 0. Who's going to know that? And the web gives us a whole load of color names to work with that match to specific RGB values. So let's take a look at some of those. So first of all, we've got red, green, and blue. We know those ones. We've got purple. They get a little bit more whimsical, so we end up with like chocolate and tomato, and some of them get quite bizarre. So peach puff and medium spring green. And I wanted people to be able to choose whatever HTML color they wanted to tweet at the dress. So what I needed was a way to get the word that they were tweeting from Twitter and send it to the dress, which is turned off. Interesting. Let's see if we can get that back again. We may have already run out of power. Let's try another power bank. We'll see. So what did I do next? Well, the first thing that I needed to do was create a Twitter account that people would be able to tweet at. I needed to be able to get the text of the tweets. I needed to convert that to the RGB values, and then I needed to send those RGB values to the board. So setting up a Twitter account is fairly self-explanatory. Once you've done that, you can apply to get access to the Twitter API, which if you go to developer.twitter.com, they'll make you fill in the form. You have to explain about what it is that you're building, because they don't like us building Twitter-like experiences anymore. So you have to describe what you're building. Then they'll say yes or no as to whether you get access to the Twitter API. But once the form is filled in and has been accepted by Twitter, then you'll have an app, which means that you'll be given an API key, which you're going to need when you want to access the Twitter API. So using the Twitter API can be done in a whole load of different ways. It kind of depends entirely on what your favorite language is. The original method that I chose, literally because I found a step-by-step video on YouTube, was using OAuth and PHP. And I already pay for hosting because I host a whole load of my family's websites, as I'm sure many of you do. So I threw the code up on my hosting, and it was working great. I had access to the Twitter API. I was able to get the mentions, and brilliant. Except one day, it just stopped working. And honestly, I know nothing about PHP. I know nothing about OAuth, and I'm certainly not a sysadmin, so I had literally no idea what had happened to my code. So I gave up and I started again, this time with JavaScript, the language that I know and love. And I used the npm package called Twit, which is really brilliant, has some really great documentation. I highly recommend it. And it gives you access to a whole load of methods so that you can get, search results or mentions timeline. So I was able to get a list of mentions that mentioned @Joe's dress. And if you want to have a look at the code of that, you can see it on this glitch link here, glitch.com/~tweetmyweddingdress. So the final thing that I had to do once I'd got access to that text is to convert the HTML color names into RGB color values. And I did that like this. And I'm sure many of you could do this more efficiently, but honestly, I was doing it in a rush. So I created an array of every single HTML color and its color name. I got this list from this website here, colorcodes.com/colornames, and there are an awful lot of them. It goes on for many, many, many lines. The eagle-eyed of you might notice a problem with the way that I'm doing this, but what I did is every time I got a tweet that mentioned @Joe's dress, I would do a search in that tweet, checking through this array. So I'd say, does the text in that tweet contain Alice Blue? Does it contain antique white? Does it contain aqua? So let's have an example. Somebody tweeted, show me chartreuse. And so I say, I get the text, show me chartreuse. I say, okay, does it contain blah, 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 until we get down to chartreuse, at which point it says, yes, it does contain that. The number for that is 1272550. And that is what I'm then going to send to the board. Now, those of you who are thinking about the way that I'm doing this might have noticed that we have in this list blue and blue-violet. So if somebody tweeted blue-violet, I would literally never get there. It would return yes for blue, and the dress would turn blue. But honestly, who's going to tell the difference between blue and blue-violet? So I put my code up on Heroku, and you can actually have a look at my little API there. So what I'm doing is I'm getting the tweet text, I'm doing the lookup through that array, and then I just send 3 numbers to a URL that is /dress. And if you go there, you should see maybe 2550255. So now we need to get the data from that URL to the board. And my experience with coding for microcontrollers was basically 0. So as I said earlier, I took heavy inspiration from the code that comes with the IDE, by which I mean I copied and pasted a bunch of code out of their examples. So the examples that come with the board are a Wi-Fi connection and a server request. And the example that came with the pixels was the RGB strand test, part of which is sending a single color to the board. So I literally took those chunks. Just as an aside, when I was learning front-end development, I was self-taught, and the way that I learned was I would copy other people's websites and then delete bits and then just work out what was going on. I really don't have a problem with copying and pasting from other people's code. I think it's a brilliant way to learn. Why write things from scratch when it's already been written for us? So yes, so if you go to File, Examples in the IDE, then you'll be able to see we've got the connect to Wi-Fi, we've got the example of how to do a GET request, and then we've got the NeoPixel changing color example. And another thing that the IDE supplies us with is this monitor, which you can print to. So you can use it a bit like your console log. Because the problem with your little tiny board is once you send the code to it, you have basically no idea what's going on. So you can connect this monitor to it using the IDE and then put points through your code to tell you where on earth you've got to. So what I've got going on here is it's just telling me that it's connecting to the Wi-Fi. So, as with many projects, it wasn't quite as smooth sailing as I would have liked it to be. And getting my API up and running only for it to break without my really knowing what was going on wasn't the only issue that I ran into. For example, the first time I connected up those little cheap Chinese knockoff LEDs, they weren't changing the bright color. So I sent red to them and they turned red. But I sent blue to them and they turned green. And I sent green to them and they turned blue. And I found out that Chinese knockoff versions of NeoPixels aren't RGB, they're RBG. So I had to swap the last two numbers over when I was sending the color down. Absolutely bizarre. The other thing that I discovered was I'd bought two different sets of lights. And one set was RBG, and the other one was RGBW, which takes 4 numbers. So the first time I connected that up, each of the LEDs were turning a different color. So I was getting like red, green, blue, red, green, blue. It just wasn't what I expected. It took me a whole day to discover a one-character change, just to add the W into the description of the NeoPixels that I was using. Nearly cried. It turns out that those NeoPixels are expensive for a reason. Buy the good ones if you can afford it. So then it was time to put it all together. I don't know if you've heard of the saying, measure twice, cut once, but I'm much more of a measure never, cut forever kind of a gal, which is exceedingly frustrating. Don't be Joe. Don't do what I do. Seriously, measure twice, cut once. So the first mistake that I made was, you know those beautiful swing skirts that flow out when you turn? I thought I knew how to make them. And the theory is that you take a piece of fabric, you cut an arc out of it, and then you cut an arc out of the middle, and when you unfold it, you fold it into quarters first, then you cut an arc, cut another arc. When you unfold it, you've got a skirt. Brilliant. I didn't measure my waist correctly, so I cut a giant hole out in the middle, put it on, instantly fell to the floor, and I had to sew little darts into it. And I hate sewing, so I was pretty annoyed at myself. The next mistake that I made was that I got super excited because I bought all the LEDs and made the skirt, and I hot glued all of the LEDs into the dress because I was thinking, I don't want them to be too even. So I don't want to space them evenly. I want it to be like a beautiful starry night. So I glued them all in, and then thought about how I was going to connect them up. And you know what I didn't consider? The direction that any of them were facing. So I just glued them all in randomly. Not only that, because I glued them all in at different distances from each other, I had to measure each piece of wire for each connection, and there are 3 for each one. It took me over 24 hours to connect the whole thing together. The one lucky break for me here was that as soon as you hold a soldering iron to the back of an LED that's hot glued into some fabric, the hot glue melts and you can just turn it so it's facing in the right direction. The downside is, though, when you're trying to solder something that is glued into netting, is that a soldering iron goes through netting like a soldering iron through butter. I mean, it just straight through there. So I burnt quite a lot of holes into the fabric. And all in all, the gluing and the soldering took so many hours. I have discovered since that you can buy pre-soldered LEDs that come in a string. For God's sake, if you're doing wearables, buy those. So this was incredibly fiddly. I think I've got some photos here of my process. And there's some of my beautiful soldering work. And the lovely thing was, once I eventually got it all soldered and connected up, I ran my RGB string test on it, and it worked. But I then got excited. I was like, I'm going to try it on. I'm going to run around the house in it. And guess what happened? A whole load of the solder points snapped instantly. Yeah. So I had to take it off, re-solder them again, and a friend of mine suggested that I coat the back of them in hot glue to strengthen the solder points, which works really well. If I had thought in advance, you can buy nice sheaths that you heat, and then they keep your solder points nice and safe. The problem with wearables is that you're constantly bending that wire, which means that you're going to get hardening, which means it's going to snap. So I went over every single LED, all 200 of them, and hot glued the back of them. And the next thing I had to do was get this skirt into my wedding dress. Now this was my dress, and as you can see, it's got layers of netting and it's got a satin underskirt. So I wanted it to sit above the underskirt but underneath the netting. And as I said earlier, I can't sew for toffee. And this was terrifying because the dress was a few £100, and when you can't sew and you're stabbing needles into your dress, scary. But I used a very loose stitch, sewed it in, and it was nearly ready to go. The last thing that I needed to do was find somewhere to hide the power supply. And I don't know if you can see them from there, but I have this very beautiful pair of cycling shorts on, which have a little pocket in them. So that's where the power supply goes. But the final thing that I had to do now to get the power supply, to get the wire, I had to cut a hole into the satin underskirt of the dress so that I could shove the USB cable through. Now, if I was able to sew, I'd have done a beautiful buttonhole stitch on this hole. I can't, so I just threw some super glue on there, and it was good to go. And yes, it's loaded. This is the only picture/video that I got of the dress, because guess what happened? I got into the taxi on the way to the wedding, and one of the solder points snapped when I sat down, and nobody ever saw it. Oh, thank you. That soothes my sad little heart. But the thing is that it didn't really matter, because I had a load of fun making a silly project, and I learned a load of stuff. And I made a thing that I was really proud of. And I was able to take it home and iterate on it. In fact, the version that I'm wearing today is version 4. If you want to come up and see, there's 2 different types of lights in here. If you want to come up and see them after, please do. And I was able to take all the stuff that I'd learned and make it better. Because when you embark on a new project, you're going to make some mistakes. And you're going to do things that occasionally make people raise an eyebrow and go, are you sure? Are you sure you want to glue all of those LEDs in there straight away? But it's okay. Make mistakes and learn how to do it better. You're never going to get it exactly right the first time. Have you heard of the phrase, perfect is the enemy of great? This is the idea that if you're aiming for perfection, you're never ever going to even hit great. Perfection is impossible. It's a goal that's going to stop you from achieving. Just get started, make something, show it to someone, and they'll probably think that it's pretty great. Something that I've found out, which is really important, is that I need to be allowed to do things my way. I don't like to plan these kinds of things. I like to just dive in with the scissors and, glue it all together when I make the mistakes. But you need to find the way that works best for you. If you like to plan every single detail before you get started, make sure you're able to do that. If you like to dive straight in, just let yourself do it. When I try and force myself to plan and measure, I get so bored I never get started. Make sure that you're working in a way that is most comfortable and productive for you. And the second thing that I've learned is that even though asking for help sometimes feels a bit embarrassing, like you're admitting that maybe you don't know something, it's okay. Literally no one is going to judge you for it. In fact, everyone on Twitter was so excited about my project. They were all asking me over the next year, like, how's it going? When can I see it? Have you tried this? Why don't you do this? And our community is full of so many lovely people who are really happy to help out. And also some opinionated people who just like the sound of their own voices, but we can ignore them. And the other thing that I would say is don't be afraid to reach out to people. The worst thing that they'll do is that they will tell you that they don't have time to help you, or they might direct you to someone else who can help you. And, you know, the best thing that could happen is that you learn something new and you get to move on with your project. And if you've got expertise to offer, please share it with other people. Attend hackathons, work with beginners, mentor juniors, attend coding clubs, and, you know, answer silly questions on Twitter. And if you're not an expert, getting involved and offering to help someone out with a project is a brilliant way to learn new things. So, I guess to wrap up, I would like all of you to leave with an idea of being excited about a new project, not being afraid to ask for help, and go out and make silly things. Thank you very much.